My name is William Dunn, and this is my video for lab number 1. Introduction. Lab 1 focuses on using household objects to demonstrate charge, induced charge, electric force, and electric field. In addition to these physics concepts, we will also be using the physics concepts of Newton's second law and gravitational force. So a charge is induced on the tape when the strip of tape is pulled off the bottom tape because electrons become stripped away. Therefore, the tape gains a positive charge. In assuming both tape charges are identical point charges, we can set up a simple system to calculate values for these charges. So two of the assumptions made on the tape are that the tapes are both equally charged and that the tapes are point charges with all charge concentrated on the center, and therefore we can set up a relatively simple way to solve for these point charges. Then we can use the concept of gravitational force and Newton's second law to set Fg equal to Fe, because the only two forces acting on the upper tape are the electric force and the gravitational force, and they act in opposite directions. So using Newton's law, we can set those two equal to each other. We can then use Coulomb's law to solve for the charge on the tape, where Fe equals the electric constant times q squared, because the charge is identical, divided by the distance squared. So observations and measurements made. So I observed the tape length to be 20 centimeters, which is 0.2 meters. And then the mass is equal to 1 gram per meter of tape approximately. So that would turn to 0.2 grams of tape, which is 0.0002 kilograms of tape. And then the distance at which the tape floats is 1.5 centimeters, which is equal to 0.015 meters. Observations made. The tapes repel each other, meaning they are charged the same, which makes sense because they were both charged in the same way. The tape is attracted to the negatively charged pen, which indicates that the tape is positively charged. And then the tape is very easily discharged, which indicates that the tape is weakly charged. So data and calculated values used. The gravitational force on the tape I calculated to be equal to the mass in kilograms times 9.81 meters per second squared, which is the gravitational acceleration on planet Earth. And that's going to give us approximately 1.962 times 10 to the negative third newtons of gravitational force. K, the electric constant, is equal to 9 times 10 to the 9th newtons meters squared per coulomb squared. The area of the tape is going to be equal to 2 centimeters, which is the width, times 20 centimeters, which is the length, and that's going to be 0.004 square meters. The area of an atom is going to be equal to the length of the atom squared, so that's going to be equal to 1 times 10 to the negative 10th meters squared, which is going to be 1 times 10 to the negative 20th meters squared. The number of atoms on a tape, you divide the area of the tape by the area of an atom, which gives you 4 times 10 to the 17th total atoms. Using Newton's second law, we can set the electric force and the gravitational force equal to each other, because the electric force minus the gravitational force is going to equal 0, as the tape is not accelerating. So the electric force is going to be equal to kq squared over the magnitude of the distance between the two tapes squared. I rewrote it there so that it can be solved. Solved for q, we're going to have q equals the square root of gravitational force times the distance between the two tapes squared divided by the electric constant. So that's going to be q equals the square root of 1.962 times 10 to the negative 3 times 0.015 squared divided by 9 times 10 to the power of 9th, which gives us a value for q of approximately 7.00 times 10 to the negative 9th coulombs. The electron deficiency, we know that there are fewer and not extra electrons on the tape because a positive charge indicates that electrons have been lost. So electron deficiency is going to be equal to the charge of the tape divided by the charge of one electron, which is going to be 4.38 times 10 to the 10th electrons. The ratio of deficient electrons to the total is going to be dividing 4.38 times 10 to the 10th by 4 times 10 to the 17th, which is going to give us 1.09 times 10 to the negative 7th. So I have a link to my code in the slide right here. The code outputs the charge and the forces of gravity and the electric force for the top strip of tape and creates arrows that also indicate these forces. The assumptions made are air resistance on the tape is ignored. The tape is treated as though all the charges were condensed into a point charge, and then we also assume that each U-tape had the same amount of charge. Here is a photo. Notice that all of the values for electric force and charge and force of gravity are printed below. The top the top sphere represents the top tape. The arrow on the top represents the electric force. The arrow on the bottom represents the gravitational force. The arrows are equal in length because those two forces are equal in magnitude. And then the additional questions asked, so if the electrons had positive charge and protons had negative charge, what would change about the observations I made with the tapes? It would mean that the charges of the tapes and the pen would be reversed because the tapes would be losing electrons and therefore losing positive charge and gaining negative charge, whereas the pen would be gaining electrons and therefore gaining positive charge. However, those two would still repel each other and they would still attract neutral objects, and because only the magnitudes of the charges are used in calculation, none of the calculations made would be different. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Tapes cannot be handled very much because they're polarized insulators, and as such, the charges on the tapes are going to be weak and very easily discharged. So when you touch the tape with your hands or with other neutral objects, the tape is going to discharge and return to its neutral state. That concludes Lab 1. Thank you.